Hello everybody and a very warm welcome to today's webinar. It is an information and overview session about the certificate programs in Python for algorithmic trading and computational finance. My name is Yves. I'm founder and CEO of the Python Quants and the AI Machine. I have prepared a slide deck which contains the main information of today. I've also prepared a case study that I want to show you later on. And based on the slide deck, I will get started with an introduction after I've introduced the agenda, and then we dive into the topics that are related to our certificate programs. I will go rather quickly to the materials. We have quite a bit to cover, even for such an information overview session. But be assured, during the program, you'll learn all the details that I'm going to present today on a rather high level only. This is the agenda. I mentioned it. The introduction will come first, then a high-level overview of the program. Then I dive deeper into the single classes and courses that make up our program: Finance with Python, Tools and Skills, Python for Financial Data Science, Python for Excel, Python for Databases, Artificial Intelligence in Finance, and a brand new class, Reinforcement Learning for Finance, Python for Algorithmic Trading, which is one of the core classes. And I have prepared a case study in this context about algorithmic trading. Also, Python for Computational Finance is the other core class. And if you do the two programs together, this is what we then call the Platinum package. Then you will get access to all the resources that I'm going to present today. I will also show you the study plan and how this works. This is the major guideline through the program, which is 12 weeks of formal study and 4 weeks of practice and final project preparation. We also provide you with review questions, exercises, and test projects so that you can check yourself and see where you stand and where you might want to repeat certain elements of the program. We have an active user forum that you can use 24/7. We usually get back rather quickly. And I will conclude today with a summary and the benefits of the program as I see them. The introduction: the Python Quants group is concerned with open source technologies for finance, and of course Python is at the core of this all. We provide trainings, we provide services to financial institutions, we run events, online events, as well as live events. We have the certificate programs, the two of them. I've authored a couple of books. I will show them in a minute. We have open source packages, and we run the Quant platform, which has some 25,000 plus users. And we're currently in the course of finishing our Quant platform 2.0, which will be released kind of soon. More information, more links and details on our webpage, tpq.io. The other major company and project is the AI Machine. That's like a natural extension of our certificate program in algorithmic trading because it allows you to deploy efficiently algorithmic trading strategies implemented based on pure proper Python code and deployed, as we call it, with a single click, with a one-click button. You can deploy your strategies, and you don't need to take care of all the technicalities and all the details that typically come along with a robust and reliable deployment in the cloud. In my case study, I will give you a glimpse at the platform there as well. And for the first time, we will soon provide access to the AI Machine to delegates that have booked our Platinum package. Here, a one-page summary of the university certificate in Python for algorithmic trading. You have access to the slide deck, and why the slide deck? You find the link here to access this one-page summary. I think it's a maximum of 2-minute read, and you get the summary of what the program is about. Here, a little bit of a lengthy version of my bio. So as we go, I'm working on, again, multiple projects. In particular, I'm currently writing a book about artificial intelligence in finance, another one about Python for algorithmic trading. Both of them will come out with O'Reilly. And I've done quite a few other things, also teaching at the CKF program at universities and running the events. So it keeps me busy, but the topic usually is the same. It's Python for finance, in different specialization areas, I can say. Also here, a link to the page where you find even more in particular about my talks. So Python and the AI for finance is what keeps me busy these days, and it's also at the core of our program. So since a while, of course, the Python for Finance book, which has become, and I'm pretty grateful for that, a standard reference work in the field, is used around the world at universities by practitioners, and also, of course, in our program. So one of the core classes is based on this book. And two more classes, AI in Finance and Reinforcement Learning Finance, is based on material that comes from a new book, Artificial Intelligence in Finance. Here you see the brand new cover, and it's already released as an early release version, raw and unedited, on, for example, learning.o'reilly.com. And my next book project, also in the making, contract assigned, is Python for Algorithmic Trading. This will also be a book published by O'Reilly. Then my two quant books. This is actually where my background is. My PhD was in mathematical finance, and here are the two books that are quant finance books that make use of Python. The other two books and the third one that is also on the list, they teach Python for finance, and here's the other way around. This is about the finance side of things, and Python is used to explain the concepts and to show how you can implement certain algorithms, for example. More details again on our webpage. Now, getting to the program itself. And yeah, it has grown over the years. Here's the brochure for the Algorithmic Trading one. It's a 16-week program. There are numbers that I mentioned, like lines of code and pages of PDF and hours of instruction, but these are moving targets. So as we go, we try to enhance, to improve the program where we can, adding new stuff where we see fit. Coming up with new classes, updating maybe material that needs some update given changes, for example, and APIs from vendors, etc. pp. So these numbers are moving targets, but I can assure you one thing, that it's getting more. It's hopefully getting better, and you will benefit also when you book our programs from updates that happen, of course, every once in a while. So you have indefinite access to all the resources when you book one of our programs that you've paid for. So it's not that we say, well, 6 months, 12 months, that's it. For sure not. You have indefinite access, and here and there we will even benefit from upgrades or additions that we put into the programs. So we try here our best to keep everybody up to date with regard to the resources. Here, see a little bit of another overview, all these pages that come with it. It's quite a bit, I must say. So if somebody would be a little bit critical of the program setup, it is that it's maybe a little bit too much for many people that work full-time. So most of our delegates have full-time jobs in the financial industry, but in particular, these are like spending their weekends studying for the program. Usually see tremendous results and success there. But you can stretch it. So the one thing is that you get indefinite access. The other is that we say, well, if you can't really get through the whole program in 12 or 16 weeks, you have relatively large degree of flexibility to stretch it. So because we know that there is like, we have family fathers and mothers, and we have people like just before the exams at universities. We have professors from universities that need to take care of their day jobs, and maybe also exams from the other end. So we have people from all walks of life, and we know that, and we try to be as flexible as possible in this regard. Therefore, we provide the flexibility. The study plan itself, sequence-wise, should be your guideline, but instead of 12 weeks formal education, you can even do it in 6 weeks if you have more time than usual, or you can do it in 18 weeks if you say, well, that's a little bit fast-paced for me, but this is easy to adjust to your personal circumstances in this regard. Why Python for finance after all? I've here a couple of articles. Here's, I think, the oldest one from 2018. It's therefore not really news that Python is something, and coding in general, that is required around the financial industry. There's hardly any financial institution these days that says, well, if you are in a quantitative role, you can get by with a little bit of theory here and there and some basics in Excel, for example. You need to be able to code. And Python is, in general, the programming language of choice that people require. And here for JP Morgan, you see the coding training for this year's juniors was based on Python programming, which will help them to analyze very large data sets and interpret unstructured data, such as free language check. Next year, the asset management division will expand the mandatory tech training to include data science concepts, machine learning, and cloud computing. And I think these are pretty important concepts. And you don't find a topic here in the list or in these articles that we don't cover. So we have, of course, Python at the core. We do quite a bit of data science or financial data science class. We have multiple classes and areas that are focused on machine and deep learning, on reinforcement learning, and cloud computing is a core part of our tools and skills class. So this is what we really cover, and I think this shows how practical the curriculum is in this regard. On the other hand, finance is good to have, but tech is what you need today. So I must confess that my PhD was in, if you like, theoretical mathematical finance. I didn't have a computational element in there, but these days this doesn't work anymore. So you need to have your programming skills, and there's hardly any quantitative PhD or thesis in general that has only formulas and text in there, and maybe here and there a figure in the table. There must be programming that comes on top. And when you read here, computer programming skills are becoming a must-have. She says, don't bother putting Excel or PowerPoint in your resume. Financial institutions are looking for R, Python, or another programming language. So it's expected that you know, like the Office suite of Microsoft for sure, but that's not enough anymore. Not even like in areas such as M&A, investment banking these days. Then we have here the third wave, if you like, the AI wave. And programming is nice, data science is pretty good, but you also need knowledge and experience, maybe even in the areas of AI, machines, and learning, neural networks, and all these topics, because they're becoming like omnipresent. And in particular, in quantitative finance and trading and investing, they are becoming more and more important and more prevalent. And this is what we cover as well. So we try to be here a little bit in front of the market, ahead of the curve with what we do, or we do it since quite a while. And what we add to the mix, I think, is sometimes a little bit early, but maybe 1 year out, it is already considered a standard. So Python for finance in general, Python for algo trading, computational finance, this is a key skill, and this is what you need today to strive in the financial industry. Now coming to the single classes, and I start with the introductory class here. It's somehow sequential, but not really. So here, when I say introductory class, this is what you get started with in the beginning, but many of the other classes start in parallel, and you will understand that when I show you the study plan. So there are classes with different focuses, but for example, in week 1, you would not only focus on finance with Python. There are also the first sessions about tools and skills and financial data science. So many of the things run in parallel, not all of them. So it is roughly a sequential presentation right now, but again, the implementation, the study plan sees lots of parallel study here, and there are quite a few synergies between the single classes as we have built the program. So finance with Python has its origin in many emails that I got that said, well, I have a background in finance, but no background at all in programming. Other people said, well, I'm a programmer, I'm a developer, but I don't have a background in finance. So I said, well, why not come up with a class that basically addresses the two topics at the same time, and we can introduce and review finance concepts, and at the same time introduce in a gentle way also Python concepts, so that we have, like, for the two groups that I mentioned before, like a gentle introduction, and for the others that have a little bit of finance and a little bit of Python, they have kind of like an easy start and can review concepts that they might have heard about, maybe not in this context, but it should be a gentle introduction to finance, Python, and the combination of both. So we cover basics of finance, like two-state static economies. You will encounter the fundamental theorem of asset pricing, static three-state economy, expressions or notions of market incompleteness, completeness, multi-state economies, and dynamic economies. So when you pick up a a quant finance introductory book, which is based on discrete finance. This is what we cover here. But always there is like the Python side of things. So it's not like that you read pages and pages. It's just like finance. No, every single concept, every basic notion is represented also as Python code. And this allows us to, in a very simple way and gentle manner, introduce programming concepts there as well. For basically all the classes, you have three types of resources. The one is the documentation, the written documentation that you see here on the left-hand side, either as HTML presented on the Quant platform or as a PDF that you can download and maybe read on your pad on the go. Then we have the videos, and we have also here the Jupyter Notebook. So when I, for example, quickly jump just for like a few seconds on the Quant platform, and I log in to the Quant platform, I can quickly show you here Finance with Python. That's currently the class that I'm talking about. And you have this documentation here with many references and the text that is relevant. And we also have reading assignments. And you see here the chapters: Finance with Python, 2-state economy, 3-state economy. Maybe I zoom in a little bit here, optimality, and so forth. So that's where you find the documentation. This as a PDF is roughly 170 pages. So it's not too comprehensive, but it covers the basics there. Then you have also Finance with Python, which is the class itself with Finance with Python 1. That's the first session with the videos. When I click on that, you see here a video recording that you can access. When you click on that, the video pops up and you can run the video here and watch everything on the Quant platform. You can, of course, have full screen here. So if you have two screens, on the one hand side, you might be watching the video on the other side. You might follow along the Jupyter Notebooks because the resources are also stored there. Here you see Finance with Python demo. So there are the resources. When I double click on this particular Jupyter Notebook, that might be now exactly the one that is used in the video, and there are more resources in general. Then you have here access to the code in the form of the Jupyter Notebook. So you see here, very simple, straightforward code, all pretty concise, nothing too involved. This is what the first class is about. So we have the text, we have the videos, and we have the codes. And many people ask me, if is there a lock-in with your platform or no. I usually stop in the middle and say, well, there's no lock-in. You can download the resources. You can execute them locally. You can play around with them. For some of the materials that we present, it's even necessary, and we encourage you to set up your own environment. This is what we teach you: to set up local environments, to work with Docker containers, and to work in the cloud. And you can download and you can access and use everything also on your local machine. But most of the materials are executable on the Quant platform. So if you say, well, I'm in an environment where I don't have just like Jupyter Notebook available, for example, you can access it via the platform. So that's a quick view on the resources. More details, of course, more instruction and overview is provided when you start with us the program. So this is the trilogy, if you like, here of the resources. Tools and skills. I've mentioned it already a couple of times, and when I say that we recommend, encourage, and expect you to set up your own environment, then Tools and Skills is the class that teaches you the tricks. And this is the basic structure. You see on the left-hand side, the introductory sessions, Python installation environments. We differentiate here in Mac and Linux, which is pretty similar. And we also have recordings and sessions for Windows. Docker usage for Jupyter Notebook setup, cloud usage as well. And these first three lesson sessions are differentiated in the two operating system worlds. From that point on, once you have reached a point where you can run your Docker container or where you know how to use the cloud, then we unify the stream, so to say. here to then introduce things like code editing with Vim, lightweight toolchain, screen Vim plus Q that it can use in the cloud, that it can use locally. We cover topics such as doc tests and unit tests, Git version control, Python packaging, documentation of Python packages, code hosting on GitHub. And we have also a case study which combines the aforementioned elements so that you see them all put together and in action. So the major goal is to have from like a professional cloud-based infrastructure to flexible virtual environments such as Docker containers, to like, of course, the Python installation, to Jupyter Notebook. And these days, more and more, we use Jupyter Lab. When I mentioned that we will come up with a new quant platform soon, everything will be based on Jupyter Lab, for example. But you will learn how to set everything up on your own in this context. Of course, you have the tools and skills also presented based on different types of resources. Here, there's not that much of a documentation, but you see there are quite a few recordings and sessions that you can rely on, and we provide also comprehensive gists with further resources. Here, the focus lies more on executable installation scripts and so forth, so that you can use more or less out of the box to replicate what is shown in the classes. So learning to use modern and proven tools for Python development and deployment. That's the guideline. Then we have Python for financial data science. I think this is probably the route where most people come to Python to do some form of data science, and in our industry, some form of financial data science. And this is based on my book, Python for Finance, a second edition. And you have the latest version, so to say, we have had already. Now is, I think, the third or even fourth reprint is in the making of the book. And we have had a few errata in between. They're all included in the manuscript. And what you find on the platform is like an HTML version of the first 13 chapters, and they are the basis for what we cover here in the class, like Python data types and structures, numerical computing with NumPy, data analysis with pandas, object-oriented programming. Visualization is something, of course, that's usually a bit more exciting, maybe in the beginning, than some OOP programming, but we cover it all, I hope. Financial time series are at the core of Python for financial data science. Input, output operations, and performance Python are two of my favorite topics because Python is so powerful, in particular in combination with pandas in these two areas. Then we have the mathematics column here with mathematical tools, stochastics that we cover. Stochastics where I'm coming from. So this was one of the first areas I used Python for Monte Carlo simulation and the pricing of American options, making use of least squares Monte Carlo simulation. So this is where I have I've got started with back in the days, quite a few years ago. But these days, it's also for me more statistics and machine learning, which is here in this part. There are two sessions, and we have then a special dates and times because dates and times are so important in the financial spheres that we have here. A separate part and an appendix in the book. You see here on the left-hand side, similar to Finance with Python, the HTML-based documentation on the quant platform. Then you have all the video recordings there, plus all the Jupyter notebooks. And of course, if you want to read along in the printed version, that works, of course, perfectly fine. You can also read it electronically, let's say on learning.o'reilly.com, which I usually recommend because via one subscription, you get access to all the books from O'Reilly and from Wiley and other publishers. So all my books are available on this platform. And the guideline here is covering the most important Python idioms, techniques, and packages for finance. So that's the guideline for this class. Python for Excel. This is something that we put into the optional category because I know in the financial industry, Excel is still kind of like a widely used tool, but not everybody is kind of interested in Excel. Therefore, this is an optional element of the program, but it's a popular one. So people often want to combine the analytical power of Python with the ease of like the fast prototyping of Excel, where I say, well, maybe I have here my little graphical user interface. Doesn't need to be on the highest professional level, but an easy to use, easy to implement graphical user interface. And in the back end, when I click on such a button, then it's not VBA that takes the heavy workload. It's maybe rather Python. And you can, what you learn in all the other classes can combine here with the ease of usage of Excel without the need to develop dedicated GUIs. So that's the class, and the tool of choice that we use there is Excel Wings. You see here, import Excel Wings. That's the fantastic tool. This works on Mac and Windows. On Mac, I think there's still a few constraints, but it works kind of out of the box on both operating systems. Python for databases. The finance discipline since years, and not only since the advent of data science on the scene, is driven by data, lots of data, and around the industry you see like different types of databases that I use. And we have this also optional class, because most people would say, well, for me, pandas, maybe in combination with PyTables is enough. But of course, maybe due to the job or maybe due to your personal requirements, you say, well, I want to get a little bit deeper into the databases class. And what we cover here in this class are NoSQL and SQL databases, as well as alternative binary stores. And after an introduction motivation, we cover MySQL, SQLite, MongoDB as a NoSQL database and object store. PyTables is pretty powerful, in particular in combination with NumPy and the array objects, as well as with Pandas data frames. Then you have this abstraction layer to the SQL world, SQL Alchemy. And because it's a little bit exotic, but it's a columnar data store, which is also pretty fast and has lightning fast compression capabilities. And here and there, I see quite interesting use cases. And we also have a comparison where we say, well, what are the advantages and benefits of the single packages compared to the others? So making use of database technologies to efficiently manage large financial data sets. So this is like what we teach there. We provide here also setup scripts. For example, MySQL is a little bit involved with regard to the installation, but we provide setup scripts that you can use to install everything in the cloud and run it beyond your local machine. And later on, after you have finished your studies and your first tries, you can destroy the cloud instance, and nothing has happened to your local machine. So this is the approach that we take here. As before, we have the recordings and the sessions. We have the scripts that help you installing everything that is out there, and you have additional resources also hosted on the web so that you can access them all kind of easily and can make use of them. So speaking of synergies, this class is recommended to get started a little bit later so that you have first experiences with the cloud, because we would expect you to run all that stuff in the cloud, again, like in a separate environment. Maybe in a Docker container this would work as well, but usually we recommend here to use the cloud. Then natural language processing, of course, getting more and more important these days, because lots of data is available in unstructured form, which means text-based. And when you think of the fact that roughly 1.5 million news articles are digested by the data service providers such as Bloomberg and let's say Refinitiv on a daily basis, that's quite a bit. We human beings, what should we do with 1.5 million news articles? Basically nothing. We can select a few and read them, but the machines are the only ones that are capable of reading through large amounts of such unstructured data sets. And we provide you with some basic functionality that we have come up with over time, so that simplify things to a large extent. And we also show you, based on a couple of case studies, what you can do with all that stuff. And you have like a blueprint to then move on and maybe use it, for example, to do some sentiment analysis on unstructured data like social media data, etc. And maybe you want to include this, even what we have done in the context of professional projects, for example, also include that into algorithmic trading approaches, real-time streaming, etc. So this is something that you can then do with it. It's not the largest class, but I think we covered the basics pretty efficiently here in this context, and from there you can move on. Now to, I know, the interesting classes for many these days, artificial intelligence and finance. This is what keeps me busy. Even this morning, I was writing in this context like an appendix where I present pure Python code to construct and to train neural networks, so to say, from scratch. So it's pretty interesting, but the book that is coming out makes, of course, heavy use of the standard packages such as scikit-learn and TensorFlow Keras, that's for sure. And on the platform, as before, you get access to the, as I call it, preview. So the book is not published yet, just like the first 3 chapters as early release. But you have access on the platform to the first 12 chapters there. So this is what we provide you with. So our delegates are the first to read through the materials that are here still in the making. So we update this every once in a while still, and I'm scheduled to finish the first draft by the end of April this year. So it's not that long that we will have the first full draft, and then it will be, as usual, like a tech review and editing, etc. But the contents itself will be roughly there at the end of April. And here is how it looks as a book. So on the platform you have seen, there is the standard ASCII doctor styling. Here is the styling for the PDF versions or the printed versions of the book, Artificial Intelligence in Finance, and the first 3 chapters already are available, among others here, chapter about super intelligence. And we are now in an age where AI takes over, so to say, and many of the traditional theories in our field are not that relevant anymore. All the details about that, during the course of many sessions that we have in the program. I just want to give you here a glimpse and some idea of what to expect. Reinforcement learning, that's also a fun class. I know that many people have heard about the success stories such as AlphaGo or deep reinforcement learning agents playing Atari games. And that's the reason why I wanted to have a little bit of fun here as well. So here is the one of the seminal papers 2013 about playing Atari with deep reinforcement learning. Here you see Breakout, there you see AlphaGo beating Lee Sedol in 2017. That's kind of like the many fantastic stories. There's like this Netflix documentation, and I know there are many fans out there, and people are eager to transfer these successes to the financial domain as well. But before we get in this class to the financial domain, we cover also some fun stuff. And in order to introduce Qlearning, for example, I've decided to go with the OpenAI gym environment, which has become kind of a standard. And we cover topics such as the card pole environment, which is a standard introductory example, or the mountain car example, which dates back to the early 90s already, or Lunar Lander, which is a traditional Atari game, which we attack based on a Qlearning agent, and where we first learn how reinforcement learning works in such environments, and lots of fun. And I think to a large extent, the fun comes here from being able to visualize that stuff. When you apply reinforcement learning or all the other methods to, let's say, pure financial data, you can have some time series charts or whatnot, but here to see like a Qlearning agent land this spaceship between the 2 flags, that's kind of like interesting and fantastic. And this is, I think, where the excitement comes, and that's the reason why I decided to include this to a large extent. So here in this context, there are a couple of examples. This is based on code and based on code that we develop with the delegates in this particular class. And when just let me check, there's a video that I've hosted and I've sent you the link, and you see it here running. This is with a Qlearning agent that I've trained. It's not like the best performing in the world, but you see the Lunar Lander now here doing its work. It takes a little while. It's a little bit wobbly. I even once said it's like a drunken captain here, left and right, left and right. There are much better agents out there, but you will see in the very end it will land it safely between the flags, and that's the goal here. And that's one of the harder problems already with the standard approaches that we teach and that you typically find. So the other problems are easier to solve as that one, I want to say. But with the same ideas and the same algorithmic structure that we introduce here for Lunar Lander, among the other examples, it's kind of like similar to what we applied then to finance. Now it has landed, and when it comes to a stop in between, it's good to go, and this would be considered a success after 410 steps. That's not pretty good. I said that there are better ones. So it takes 1 minute But you see here, that's real fun to train agents that afterwards fly your spaceship here and can land safely. There's the mountain car. This is also a nice one. Mountain car down here. When it runs, here the problem is that the agent learns to behave in a way that the car gets enough momentum to the left and then gets the momentum to get to the right. So again, this was a problem that was devised already decades ago, actually, and here it's a pretty nice example to illustrate. And it's an easier example than the lunar lander example. So this is what we do in the class, but we apply this, of course, to financial trading as well. So the major goal is to build a trading bot, and we also show how to deploy the trading bot in practice. Now we come to one of the core classes, Python for Algorithmic Trading. Here you see like the basics are required. Then we dive into vectorized backtesting, prediction-based trading, event-based backtesting. We have here in Algo Trading the streaming data story. Then we cover 4 platforms: Wonder, FXCM, Interactive Brokers, Gemini, and automation and review. That's like the core at the core. And the experience modules are practice module 1, practice module 2, and final project, the research paper that is to be written. So this gives you a rough overview. It's not a complete overview, but it gives you an idea of roughly how this works over time, right? This is the first week, second week, third week, we have some special financial data science, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. So this is really now along the weeks, 12 weeks, and then you have the 4 weeks for the practice module. So a rough schematic overview. It's not exact in terms of like the size of the boxes and how they compare to other, but it gives you like the overview of the program. From a theoretical point of view, I typically think in 7 layers. We start with the infrastructure, be it cloud-based, local, Docker, work with financial data, formulate the strategy, do the backtesting, be it vectorized or event-based. Then we cover connecting code to the platform or maybe in simulated fashion. We implement the trading code, and then we need to automate that. So these are my 7 layers, and I use this pyramid chart since years now, and it's still valid and appropriate from my point of view. And it structures our thinking, and it structures also the program itself. Then we have a masterclass just recently introduced, where we cover Wonder to some higher level of detail. And the goal is to be able to then work better with the AI machine, because I said for the first time we will grant access to Platinum delegates to the AI machine. So here it's all about Wonder, reviewing certain topics, going deeper with other topics, and then have like the interface to the AI machine. Now the case study. I've gone through the core class a little bit quick because I have here for this core class the case study, and it's about the Wonder trading platform. Backtesting a simple trading strategy, deploying the trading strategy, and deployment with the AI machine. Maybe let me in the meantime open the Wonder trading app. This is now a paper trading account, which is easy to set up, some 2 minutes. And it's now loading the data. And the strategy that we're going to test for Wonder is Euro, US dollar, 5-second bars, and 2 simple moving averages, 3 bars and 6 bars. So I've chosen these very short term parameters here due to the fact that I want to do a demo here. Otherwise, I wouldn't recommend to go neither with 5-second bars, also probably not with 3 and 5 bars here for the simple moving average, but this allows me to have a quick demo and to see some results. Now we are in the case study, Algorithmic Trading. I have executed the first part of this Jupyter Notebook because data retrieval takes a bit. Here you see I'm connecting to the Wonder API based on a wrapper package that we provide you with, TPQOA. I'm retrieving data for Euro, US dollar, 23rd of March to 27th of March, 5-second bar mid prices. So this is 4 days. 5-second bars, and this translates into quite a bit of data. You see here it's 58,694 data rows in our data frame. And when I plot the closing prices, this is like the evolution of the US dollar currency pair quote over the last 4 days. 27th here means when I retrieve it, 27th, the package behaves in a way that we get data for the day before. So we get until just before midnight, we get the data. So 26, 11 p.m., 59, blah, blah, we get the data. So 27th is excluded. So for 4 days worth of data. Now simple moving averages. We calculate the log returns. I calculate the simple moving average 1 here with 3 bars. Simple moving average 2 with 6 bars. Do a drop NA. Here I show you the visualization. So it's since we have 50,000 data points plus, I cannot really visualize the whole data set. I can, but you wouldn't see something. So here you see like the shorter SMA is green, the longer one is SMA2, albeit short and long is relative here. So I see all pretty close, but that's not the point. I also don't want to show you here explicitly a profitable strategy. I just want to show you a complete life cycle here. And the strategy is easily translated into predictions and positions here. When I say, these are my indicators shifted by 1 day, so I avoid foresight bias. Here I derive the position, +1 for long, -1 for short. That's the number of trades, or you see 10,000 trades over 4 days. This would like eat up every profit potential alone, given the transaction costs. Here I calculate the strategy returns, and these are the results. So the underlying makes +3%, the strategy +5%, roughly speaking, and here you see the result. So that's not the best strategy in the world. It seems to outperform somehow, but again, this is not my major point here. The major point is to show you a complete strategy lifecycle. And when we want to do algorithmic trading, here you see I can stream data, and that's one of the prerequisites, that I can get real-time streaming data from the API, and this is what Oanda provides us with. I stream Euro US dollar at this point in time. This is GMT time on my local clock. You see here, this is CET, so Middle Europe, Central Europe. And I can change the on-success method, which currently only prints out. And this is how deployment works. And you see here now a rather concise class that I use for the deployment. There's just the double under method in it, special method in it with a couple of parameters that we need. Here we do the data resampling. Here we do the data preparation in real time. It will be happening. SMA1, SMA2, and the positions are derived here. Here I report trades that happen, and this is the on-success method that I use. And I can have 2 signals, a long signal or a short signal for this little strategy. And when I'm neutral or short, I check for a long signal. When I'm neutral or long, I check for a short signal. And depending on which signal now is relevant, or which constellation, it places a trade or it doesn't place a trade at all. I mean, it can stay in a position for sure. It executes a trade, creates an order, it reports the trade, and changes the position accordingly. So this is just to show you, not to teach you the details in that sense. And when I execute this piece of code here, this class, here I instantiate now a trading object, and I get started with the trading. And trading first doesn't start immediately. What starts here is the collection of data until we have enough data together to form the first trade. And here in my overview, there is no open order, there's no position actually here, no trade. You see, this is all empty. And once we have enough data collected, which means roughly 5 seconds times 6 bars, 30 seconds plus a bit. When it has enough information, it will get started. Now it says going long, 1,000 units. Here's the price. The P&L is 0, no realized P&L. And here you see 1,000 units long And you see in real time now the trade plays. You see here also the trade plays. Makes slight tiny profit. That's good when it currently markets are of course underway with a little bit of a higher volatility, and the signal obviously was good. And you see here also the 3 and 6 bar simple moving averages. And here the signal seems kind of good because now Euro US dollar is going up. Of course, we don't have too much volatility in the currency pair here, but it's building up a slight profit here. Maybe there's a crossover now coming. And it has stopped trading already. So there was just one trade because we got like in the up, because I didn't want to get too long here with regard to the trading. I just stopped here after 150 ticks. And since there was no other trade, we have realized now the profit of 0.38 here and went neutral. So this was just artificially because I stopped it here at 150. So that's the that was my hard break here. This was just artificial, arbitrary. Of course, in reality, you would let it run much longer. But we have placed automatically our trades and even made some profit. I wouldn't have expected that. And here, no open trades, we have cleaned it up. And with the AI machine, this works similar. So here in the AI machine, you have such a trading strategy here as well. SMA, and there's now a little bit of code, maybe a little bit more than the standard one, but you get quite some flexibility. I have set the parameters to the very same thing. So 5 seconds, Euro US dollar, SMA1, SMA2, 23rd to 26th. Here 26 is included. I don't need 27th. And you see the code here to implement this strategy, the SMA strategy, is 66 lines. And there's quite a bit of, let's say, housekeeping here. It's not that complex code here, for example, the calculation of SMA1 and SMA2. So that's the strategy that we have. I can then go and here do a confirmatory backtest where I say, well, let me do a backtest here, SMA 5 second, 3 bars, 6 bars. SMA, here's the model, 3 bars, 6 bars, and testing an end period. So 5 seconds. Let's backtest the model. I'm going to do a quick filter here. These are just the SMA ones. I've done already a couple of backtests. For example, that one is with the same parameters that I've done. And that's with other parameters. But this was with the parameters, same parameters. I can open now. Backtest is implemented. We see here the results presented only out of sample performance. Accuracy is not that high, but this is just like for illustration. The curve here is similar to what we have seen before. We also see the red curve after transaction cost. I have cheated here a bit with regard to transaction cost so that it doesn't look too bad, because with the 1,000 trades or whatnot, we would have like pretty negative result. So now we come to the one-click deployment, and let me quickly check. I think I have running something. Nothing is running there. That's okay. So let me get back to the backtest, and I say now go live, and I go maybe with account 2 here, quantity to trade. Let me quickly. Maybe I go with account 3. Oh, we have a couple of accounts here in this thing. Stop loss distance, take profit is trailing stop loss, number of bars. So toggle number of allowed stop losses, model level stop loss, etc. So here are the profit capture parameters. So where we say, well, if we have reached a certain profit target, we do a position offload and adjust the trailing stop loss. And I'm now starting this model. Let me see if it trades. I don't. Here we have now this one running model, but I need to, let me check something. Yeah, it has placed its first trade. First trade is placed, account 3. You see the P&L starts immediately. And again, this was just like my one click here. So my SMA-based strategies, you see here, when I say go live, I have a couple of parameters. Risk management is the primary focus here of the parameters. When I then say, okay, deploy it, we have deployed it now and it's running, making a tiny profit. When I have a look, you see here the P&L, unrealized, realized, and you see in real time now the visualization of the strategy. And this means, among others, here in this context, that we see all signals. Long position signals means here the triangle up or down, and we see red is a wrong signal, green is a correct signal. So this works for 5 seconds, but again, economically, you see here with like a few trades, and it has changed the position here again. So this is not like a viable strategy, I would say. You might be lucky, but overall, it's with a 5-second bar is not a viable strategy. But you see what I've done here in the Jupyter Notebook, retrieving data, formulating the strategy, doing the deployment, is standardized with the AI machine. And with a couple of clicks, once you formulate the strategy, you do the backtest and you do the deployment in the cloud, and you get all the convenience here with the real-time visualization and full audit and log here. All the details are available for such a strategy, what has happened, what was the data, which signal was placed at what time. So this is what the AI machine is about. Just to give you a glimpse here of how this works. And of course, you can always control what's happening via the under apps. So this was a pretty quick overview. Python for Computational Finance is now the other core class, which gives you, there was one question related to what I was showing. Yeah, you can add trailing stop losses. So this is what I've shown. We can easily manage trailing stop losses. You can even dynamically adjust your trailing stop losses, right? So Python for Computational Finance is the other core class, where we cover market-based valuation, complete market models, risk-neutral valuation, Fourier pricing applications, American options, the general market model, which includes stochastic volatility, jump diffusion, and stochastic interest rates, Monte Carlo simulation, calibration, hedging, revenue, and practice. So this is based on my book, Derivatives Analytics with Python. Of course, with updated codes, everything is up to date with the latest Python, Pandas, NumPy versions. So this is really like at the core of financial engineering, I would say, and allows you to do proper equity options pricing, hedging, and calibration of models, etc. So here you see the books, and for the book, or the book, not the books, not the plural, the book, Derivatives Analytics with Python, all the resources are available on GitHub, but we cover this in detail, and this is one of the reference books that you should have available when you want to do computational finance. Everything else is kind of included. We also cover DX Analytics, which is our pricing library and package, which runs more or less in parallel with the other class, but it's, so to say, a class in and of its own. We have quick start, framework, model simulation, European valuation, and derivatives portfolios is something that is revisited every once in a while. Fourier pricing, American valuation, stochastic short rates, multi-risk derivatives, implied volatilities, calibration, and hedging. So that's quite a bit what we cover here. DX Analytics has in and of its own also a comprehensive documentation with, 14 Jupyter notebooks that come along with it. So you have, of course, access to that as well, because it's open source, it's out there. But we go, I think, in certain areas a little bit deeper. And here you see the overview. It's like risk neutral present values, and Greeks for instruments, positions, and portfolios. This is what characterizes DX Analytics. So we go into the details, how this all works, what the architecture is, what is different to other packages, and how does it work with the risk neutral discounting, etc. pp. So this is also what people sometimes call global valuation, but it's fully Python, global valuation, consistent, non-redundant modeling of such risk factors. Also here, now 8 layers: infrastructure, financial data, model simulation, Fourier pricing, calibration, market valuation, hedging. So these are 8 layers in this class. The study plan, I mentioned the study plan a couple of times. This is just like the guideline page. Here is the plan itself. You see the 2 core classes, first and second column, they go together for the first 3 weeks. Then we have them separated, left and right. This is now for the current cohort. We are in week 11 for the current cohort. This is current as of 21st of March. And there you see the live sessions. So there have been throughout 2 live sessions, tutorials are added here. So as we go, financial data science, you see the topics, tools and skills. One of the more comprehensive classes here, AI in finance, and the new class you see here, Learning. Whenever you see Learning, this refers to reinforcement learning. So in addition to AI in finance, which has 12 classes, we now have R reinforcement learning with 8 additional classes only focused on reinforcement learning. In the optional category, you find Python for Excel, object-oriented programming, some deeper stuff there, Python for databases, and NLP, the classes that we covered. So this is your major guideline, and you would go through week by week. Even if you might take 2 weeks for the first week, the sequence is what you should follow here. That's the important part. Review questions, exercise, and test projects. We have 4 sets of review questions. Each set of review questions covers 3 weeks. And this allows you to review the most important topics, at least what I consider the most important topics for the algorithmic trading program as well as for the computational finance one. So these are rather questions. You can write them down, you can answer them. Maybe you can dictate them into your phone, for example, but they are not really like formal exercises or whatnot. This is more like, well, yeah, indeed, there was this interesting topic. I need to review that. This is what is meant by, or what the intention is of the review question. But we have formal test exercises that are sometimes pretty simple and close to what is covered in the program. And sometimes they're kind of involved. And if they are really involved, then we have these little test projects. This is the very first test project. So this is not involved, but we have test projects where people need to spend quite a few hours to come up with proper solutions, right? So, but they are all related to what we do in the program. And of course, you will be presented with example solutions. Not for everything, so I do this intentionally, but for, let's say, 80% of the stuff that we present there, you will also find example solution. But I always say, even if you don't have time to solve the exercise and test project, save them for later, study them later, and only then, when you have tried your best, revert to the example solution. So this is really to test yourself and to see how far you have come, and should also prepare you for the practice phase and for the final project. If you have questions, and everybody has questions, of course, you have the user forum. And some people say, well, can I write email? If you post something in the user forum, our whole team receives emails. So everybody is informed for every entry in the user forum. So no need for emails. We want to centralize like the technical questions and answers, and you have a couple of boards with regard to the platform, the program, the different core classes. And this is a pretty old screenshot. So here you see, I don't know, 1,000 entries for Python, for algo trading, etc. But the rough idea is really that you have the user forum, you can revert to the forum, you post it, you can post code with syntax highlighting, etc. And everybody has a benefit from that. And not only us, maybe others can answer as well. Even there are some, let's say, social quote unquote entries where people reach out to others and where they do stuff together. And this is what we encourage here as well. So it's like the social part of our platform where you can ask questions, you get answers, and yeah, it's really like your go-to means when they say, well, lots of resources, and I understand it to 90%, but here the 10%, I don't know, I cannot get across this chasm. So please help. And this is then when you would revert to the user forum. So you have it now seen it all. I think it's pretty comprehensive. We have lots of resources. It's all pretty practical. It's, of course, quite a bit of theory as a background, but it's not a theoretical program. To the contrary, it's a pretty practical program. And our goal is to empower you to build, for example, your own algorithmic trading business, to be able to implement the latest in computational finance with regard to numerical techniques, etc. So you should be empowered to do it on a practical, many areas, even production-ready level, right? So this is our goal, to empower you in this regard. And when I should summarize and mention the major benefits, here is my list of 8 points. I think it's a comprehensive, finely tuned program I mentioned it, we extended, we expand different topics and try our best to keep it up to date. I think Python is the key skill in modern finance. There's hardly any job description out there that is related to quantitative finance which doesn't list Python. We have, and in these new days and these unprecedented times that we are currently living in, I'm so happy that we have an online program. I always saw the benefit of online programs in the flexibility and scalability, but I never thought of it really as a safe and efficient and flexible way to study, even in times where some people around the world cannot leave home, and where we have social distancing and all these new concepts that or new facts of life that a year ago or even a few months ago nobody would have imagined. So I'm pretty happy that we are able to still provide the same level of service and education and training as before in a safe, efficient, and flexible manner. We have a detailed and comprehensive documentation. So it's not only that we give you thousands of lines of Python code and say, well, see how it works for you. No, you have the documentation. You can always reference the documentation. But of course, we have the readily usable resources as well. You get access to all the notebooks, to the codes. You can download them. You can make use of them. You can deploy them in the cloud. You can replace the strategies that I show with your own strategies. So that's the major goal of the programs. You also can earn a prestigious university certificate after successful completion. So there is no automatism here. You need to hand in a final project, which is graded and which passes the minimum requirements. And usually we have like 2-3 rounds of feedback and rework there. But if you put in a little bit of effort, the university certificate is on the horizon. Another now financial benefit is that we still have super early bird pricing until 4th of April. So this translates into some 20% plus discount. These are the best prices that you can get. And if you belong to special groups, let's say academics, here and there, we sometimes consider also regional discounts, where then even better. So, but currently is the time where you get the lowest fees for the whole program. They won't get any lower anytime soon here in this context. And you can enroll on the home.tpq.io certificates. There are the 3 options, either for Python for algorithmic trading, or for Python for computational finance, or for the platinum package, which involves both. This will be the complete study plan. And the next cohort starts at the 18th of May, 2020. So it's a little bit of time left, but recall super early bird pricing ends at 4th of April. And you can also reach out via training@tpq.oa. And there's a question that I'm getting asked quite often. What is kind of like the job market perspective when I earn this certificate? I think you improve your chances considerably, but since I cannot know the background and curriculum vitae of everybody out there, it's hard to judge what impact our certificate has. So just today, somebody said, well, I reached out to colleagues and I said, well, your program obviously seems to be on a high level and on a high professional level, highest quality. The industry knows me personally. Many know me personally. Most know what I do and what we have done with the Python quant. So you can be assured that when you have the certificate, it improves your outlook in terms of the job market, but I'm not in a position to guarantee you something out there. But the more effort you put in there, the better the portfolio that you build and maybe put on GitHub. I cannot imagine a situation where this wouldn't supercharge your career and would make what you do, what you have to offer, future-proof. Because this, what we cover, is part required today already, and part is what I said, we are in front of the curve. It's cutting edge. So for what we do, like reinforcement learning and finance applied to algorithmic trading, etc. So I think we have the most comprehensive program. Some of that is already required as standard today, but many elements that you find, you will hardly find in any other program or offering out there. Having said that, I wish you all the best, and in particular, happy Python coding. And in these days, take care and stay safe. I would, of course, be grateful and happy to see you in the program. If you have questions, reach out to training@tpq.io. We are there to answer your questions. And yeah, take care. Bye-bye. See you in the program.